So last semester, I had the opportunity to work on a directed studies project under Dr. Shivan and Balram from the Department of Geography. In my directed studies, my goal was to examine the use of geographic information systems, or GIS, in the planning of municipal waste management systems here in Surrey, BC. I was interested in waste management in 2015 when my team worked on a project in a course called SFU Change Lab. In the project, my team worked on a social enterprise to reduce landfill wood waste in the city of Vancouver. Because our project was well received by the Vancouver Economic Commission, I was inspired to continue working on areas related to waste management up to this day. But in order to understand or improve the waste management systems we have to first understand what they are. So there are a couple of definitions for waste management. I would focus on the second one at this time. UNISA considers it as a series of processes involved in the collection, sorting, transportation, and the disposal of waste in a city. You can begin to see that with this definition that you can apply GIS concepts to improving the systems that we have. Throughout my literature review, I've discovered that GIS has been used to, for example, estimate the volume of waste for collection, and also to select landfill sites or landfill facilities based on land sensitivity, so all of which use GIS. However, in my literature review, it was clearly lacking that we didn't have a systems or a network-based approach that took the collection all the way down to the disposal in analysis, which is what I tried to address in my directed studies. So there are three main steps in my analysis. The first of which is to identify out of all the waste bins that we have in the North Surrey community in Surrey, BC, out of all of those, which ones are high volume. Unfortunately, municipalities have a limited operating budget, so not all of these bins could be given a second one to reduce litter, overflow, or other problems with the bins that we have. So a combination of spatial analysis and a location allocation tool in ArcGIS allowed me to identify not only which of all the bins are high volume, but also identify where around them a second bin could be placed within walking distance from each other. After that, I could create a service area analysis in which I could differentiate and understand where these bins are in location, in relative location to the Surrey transfer facility, which is the current official facility that takes all these waste from the North Surrey community to disposal. So in this sense, by understanding which breaks, we can begin to understand whether or not other facilities could be better suited to take these bins or to maintain the bins in this neighborhood in order to reduce fuel costs, transportation costs, and to prevent a slower response times for fleets of vehicles because of traffic congestion, for example. In this way, I could do that with a location allocation tool in ArcGIS again. And as you can see here, for Cascades Recovery and Bright Sky Disposal, even though they are private facilities, you can begin to understand and figure out whether or not those facilities might be better suited to service the neighborhood. As you can see here, even though with the weights are 0.5 and less than the Surrey transfer station, after the analysis, you can see that demand for both of those facilities are higher than the Surrey transfer station, as well as the distance between the facilities and the bins are only a fraction of what the current facility has. So in this sense, from here, you can begin to apply further studies to understand whether or not there might be more effective or more optimal alternatives to the current system that we have. So in conclusion, my directed studies attempted to address multiple stages of the municipal waste management system with a GIS analysis, especially with a networked approach. By doing so, municipalities can save time, costs, operating costs to maintain these services. As well as number 3, GIS can be used to explore efficient or more optimal solutions to the problems that we face today in our communities. Thank you.